Remember how we like watching Coyote and Roadrunner cartoons in class sometimes to look at energy? Well, here we're going to explain some, and please don't laugh at the drawings. You know I'm not great at them. So we have a cliff, and we have Coyote up here, and we have him putting a boulder on that cliff to drop on Roadrunner down below. Beep, beep. Now, he is going to be giving energy to that boulder to get it up. Yes, I know this doesn't look like Roadrunner, but use your imagination. Now, he's got to give that boulder energy to get it up the hill. And once he's got it up there, he's given it gravitational potential energy, because the gravity is going to pull it down as long as he gets it to the edge of the cliff. Now, there's other ones we had as well. We had Coyote trying to pull himself into a rubber band so that he can shoot through the air and catch Roadrunner, who is an awful lot faster than him. The potential energy that we're using there, of course, is going to be elastic potential energy. Now, with both of these, he's put it into elastic potential energy, he's put it into gravitational energy. What type of energy does it turn into to get to Roadrunner? Well, if something is moving through the air, we call that motion energy, or a lot of your books will call that, because they forget there's other types, kinetic energy. The kinetic energy with motion in it, because you're actually moving from one place to another. So he's actually got it, turned it into gravitational potential energy, and as it falls, it's losing height but gaining speed. It's speeding up, so it's actually changing into kinetic or motion energy. Same here. He stretched the rubber band out, given himself a lot of elastic potential energy. As soon as it's released, he's going to fly through the air. He's going to speed up so he can try and catch Roadrunner. And I think in the cartoon he actually bypasses Roadrunner and then slams into a great big wall, and then he gets a bit squished. But either way, you've got elastic potential energy turned into motion energy again. And the last one we have here is dynamite. Now, anyone who knows anything about dynamite knows that you get great big explosions happening with dynamite. Now, where did the energy come from to make the explosion? Most of you will say, okay, it starts out as a little thing and then it just explodes and there's heat and light. Well, only certain things blow up. And that's because only certain things are made of chemicals that are very unstable, and there's huge amounts of energy holding them together because they don't want to be together. So they're really, really tightly bound with lots of energy because they really don't want to be together. Think again of the bulls stuck in a pen together, banging at the walls, trying to get out because they really don't want to be together. So if you break these bonds here, you're going to release not just a little amount of energy, but a huge amount of energy. And when you do so, you're going to have kaboom! And that's exactly what the dynamite's about. We have chemical potential energy, releasing lots and lots of energy when you break those bonds, and resulting in the energy released is not just motion energy here, although if it's near you, you will certainly have an awful lot of motion in your body because you'll be flying through the air and sometimes you'll be ripped to pieces with the motion. But you'll also let out lots of heat and lots of light energy as well. Now, the last thing we're going to quickly cover here is how do we put all this in a picture? How can we actually take each one of these scenarios, or the ones that we do in the lab, and put them into a picture to help us understand what's happening, what sort of energy we're starting with, what sort of energies we get to? Are they energies that are being transformed or transferred? And once we understand that, we can then figure out where can we improve it or change it to make it do what we want.